My name is Fermín Navarro Medina. I'm a professor at the University of Vigo at the Engineering and Space faculty in the campus of Orense. I'm a member of a research group called Aerospace Technology Research Group, and this is one of the projects that we are working on. WiPTerm is an H2020 project formed by a consortium of different partners. IP is from Portugal, the University of Porto. In Portugal, we also have Centi. It's a nanotechnology center focusing also on smart materials. In STEC, it's an additional technological center. In France, we have the University of Limoges. I will describe what each of the partners does, and then we also have the University of Vigo. The WiPTerm project focuses on the design, implementation, and testing of an innovative wireless energy transfer system consisting on plasmonic a hybrid photo-thermoelectric plasmonic device, which I will call HPTP from now on. What it does is to transform the energy coming from a laser into thermal energy, which is later transformed into electrical energy or electricity. What we want to do with the project is to explore the possibilities of using this wireless energy transfer, which could be used in a CubeSat technology. On the screen, you see a concept of operation image. There's a space vehicle with a laser generator that would send a laser signal to the HPTP, to the plasmonic panel that is installed on a CubeSat. The requirement for this panel is that it can redirect the laser energy to specific places that act as heat concentrators so that they create thermal gradients that are used by thermal cells that transform this thermal energy into electricity. The power system of the CubeSat needs to be able to store and use this energy, and also the panel, the HPTP, this energy transformation device, must not increase the temperature of the CubeSat. This is one of the key elements of this technology. The main objectives are to develop this technology to a tier L3 level, to integrate this device in a CubeSat, also to test this device in a lab environment from a 10-meter distance, and then to carry out this test in with 500 meters of distance, and then also to model the behavior of this HPTP in a space environment. Secondary objectives within the project, we have the possibility of loading batteries with this system. This would depend on the level of development acquired by the end of the project in terms of the power generated in the destination. As a secondary objective, we want to analyze the feasibility of this kind of distance energy transfer in other scenarios which are not of a terrestrial kind. If this device can be used in planets that are not Earth, the competitive advantage or the disadvantage of other more traditional systems like solar panels, well, this could be used in remote planets, for instance, if it were to work. In the consortium, on this slide, you see an outline of the WiPTerm space segment. We have the CubeSat system, the HPTP system, that would be the energy transformer, and then the laser generating system. The creation and development of thermoelectrical cells and the panel where they are placed in the energy transformation device are in the hands of the Oporto University. Everything related with the generation of electricity and its control through this device that Thenti is responsible of that. At the University of Vigo, we are in charge of the CubeSat subsystems in order to integrate the HPTP system in the CubeSat. We focus on the main interfaces that are directly related with the HPTP system. That would be the onboard computer, the structural subsystem, and mainly the thermal subsystem. The University of Limoges is in charge of the development of the laser itself. So in this integration of HPTP in the CubeSat, what we are doing at the University of Vigo is to adapt the CubeSat design in order to integrate it based on the definition of interfaces to integrate them correctly. Also to define the concepts of operations or operational concepts so that the system can be feasible, and also to carry out tests in similar environments at the component and system level. This image is an example of the different setups that we are thinking of, in which the incoming energy from the laser would impact on a metal panel, which would concentrate the heat on these small cones in order to generate these thermal radiants, which are used by the thermoelectrical cells to transform this energy into electricity. As part of our responsibility in this project, we are working on the mechanic design of the CubeSat and the HPTP within the CubeSat. We are also in charge of the structural and thermal design, as well as the assembly, integration, and verification through the testing of the HPTP device in the CubeSat, both in a vibrating bed and on a vacuum chamber. The expected impact is to contribute to a new technology in the field of CubeSats to transfer energy remotely. The identification and characterization of scenarios for space applications, but also within the scope of the project, we have the establishment of the efficiency and limitations of the system. On the other hand, the impact must be the contribution to the creation of a community of scientists associated to this technology, as well as the identification of new applications for the use of this way of transferring the energy remotely. This all would have to do with systems that require energy in remote locations. What this system can do is the following with the advanced development. Well, when the system develops, we could cover larger distances. Here you can see 3 fields of application where the HPTB could be used in the field of transportation, mobility, or exploration. Some examples in the field of transportation could be, for instance, to charge flying drones or charging stations for electrical bicycles, etc. That is, devices which are in remote locations and may require this solution. In terms of mobility, the charging of electrical devices in remote places, that is, for instance, to use sensors or equipment for autonomous vehicles, for agricultural uses, bridges that may have sensors to detect vibrations in high altitude, or maybe in terms of exploration, all systems that are, for instance, robots that are in caves in the moon or Mars could be charged with these systems, or in the event of a solar eclipse, CubeSats could be charged when in a situation of eclipse. To conclude, I would like to talk about the future work that we want to do. After the WiPTerm, when WiPTerm is over, then we will have to work on the physics and engineering of this HPTP. Also, in the laser to cover larger distances with much more efficiency. And also the demonstration in a CubeSat in space of this technology. This would be one of the next steps. And other applications in which would not be this specific one, to use this device for the transformation of energy. Thank you very much. I'm at your disposal if you have any questions.